Welcome everyone. So as usual, this is Kodro, and now we are day 30, I think. So we have been streaming for a year. As usual, this is Kodro, and today we're gonna solve some lead code problems. Yesterday we did some binary tree search problem, and today we're gonna do some graph DFS problem. So today theme is about Assassin's Creed Brotherhood mission. I already did this problem. Today we're gonna try to solve those three problems. Hopefully you do two or three of them. So the first one is number of provinces to identify distinct function within the Creed network and strengthen alliance. So without further ado, let's go to the lead code problem. But before that, you can reach me through those social media platform. You can find this my profile on GitHub, and you can find me on Instagram or on LinkedIn. And recently we did a server on Discord to connect with you better. So if you like this content and if you want me to continue doing this content, you can subscribe to the channel. You can like the videos. Really, so all the comment, and I'm really happy to help you and to connect with you. Thank you everyone, and without further ado, let's go to the lead code problems. So as you said, today we're going to do some DFS, some graph DFS problems. Okay, so we already did this, and today going to do this problem. Let's bring our illustrator and let's go. So here, so this is the problem of yesterday, and today I'm gonna do something new. So there are n cities. Some of them are connected while some are not. And we have here the summary of the video of yesterday, which contain how to deal with graph DFS. So we have this here, and to help us solve this seed code problem. So there are n cities. Some of them. Oh, let's put music. Hope the sound is okay. Okay. So let's go. So there are cities, some of them connected while some are not. In a city, A is connected directly with city B, and city B is connected directly to city C. Then city A is connected directly with city C. Oh, okay, so city A and city B are connected, and B and C are connected. Okay, so let's draw it. Okay, so we have A and we have B and we have C. So A is connected to B and B connected to C. So A is connected to C indirectly. A province is a group of directly or indirectly connected cities and no other cities outside of the group. So this is a province. You are given an n multiplied by n matrix is connected, where is connected I of G equal 1 if the city I, city G are directly connected. Okay, and is connected equals 0 otherwise. Okay, so return the total number of province. Okay, so I have 1, 2 and 1, 2, 3. Let's take this example. Let's delete this. Okay, so we have two cities directly connected, and the third city is not connected to them. So the matrix should look like this. So I have three cities, so it's 3 by 3 matrix. So 0, 1, 2, 3. So 1 is connected to 2. Then it will this 1 1. Okay, so 1 1 0, 1 1 0, and 1 1 0, and 0 0 1. Okay, so this is 1 2 3, and this 1 2 3. So 1 connected to 2, and 2 connected to 1. Oh, and the diagonal is always gonna be 1, and the 3 is connected only to itself. 3. Okay, okay. So the diagonal will be always 1, and the others will be, if they are connected, will be 1s, and if they're not, as this the second test case, no city is connected to another, so we're gonna only put 1s in the diagonal. Okay, so we have to output the number of provinces. If there are 3 cities which they are not connected, we're gonna simply return its number, which is 3. And if they're not, so this is a province. So this is a province, and this is another province. So these are 2's. Okay. Let's go. Let's put that Python. 3. Okay. Let's gonna change this. So how we're gonna do it? How we're gonna do this? Okay, so the thing we're gonna iterate through n and mark if it's visited or not. Okay, so if visited, so return. If not, neighbors of graph. How are we gonna do this? It's once connected to. So I think if it's connected, so I'm gonna make a counter. If it's connected, I'm not gonna number of nodes in a graph. So the n should be the number of the n, which is here, n by n should be the number of nodes, which is the size of this list. I think we're gonna G adjacency representing graph, and the graph it's connected, and then we're gonna make a visited to see if we already visit this this node or not. Okay, so and then we're gonna choose the recursivity. This kind of problem will be solved with recursivity. So if it's visited, I'm gonna return, and if it's not visited, I'm gonna make it true. Then neighbors. Hmm. Hmm. Okay. Neighbors. Next. How am I gonna? Hmm. Okay, so I'm gonna start with making n equal the length of the matrix, which is connected, which gonna give me the number of node I need to loop through. So it's connected. Then I'm gonna make a list of visited equal false multiplied by n. So this is a list of visited node. If we didn't visit it, we're gonna initially make it false, and if we visit one of those, we're gonna make it true. So I'm gonna define a dfs, which is gonna have the can I define it inside of these or not? I think I cannot, but I will try anyway. So how we check if we visited this node or not? Matrix of mm-hmm. So we know if our node, so let's say we are let's say we are here. So in the matrix we are in this 1 1. To go to here, we have to check for the for this we have to check for the line and see what where there is a 1. So if we find a 1, then we can go to this node. Okay, so and if we find like 2, we can go to the next line. In the 2 we will not consider the diagonal. If we find another, okay, so this is a 1, so we'll have 1 as a, we have to create a, I think so this is true, we're gonna set up the diagonal for true, and then if we go here, so we're gonna make this true, and we're gonna make this true also. And then we count the number of true, and I think divide them by so we have here two trues, so one true. Oh, so all the trues are a one city province, and the all false are. Hey, hello, okay. I can stream. How was your day? So every group of two is a province. Then we're gonna. No, but. So every false, it's a province. So if we count the number of false, we're gonna count the number of individual cities that represent province, and every group of two is a. I just cannot, like, if it's like this 1 3 1 2 connected, 3 4 connected, and there is 5, so the matrix will be like this: 1 1 1 1 and 1 and the diagonal, and then 1 2, this 1 and 2 1, it's 1, 3 4, so 3 will be 1 his and 1 here, 4 3 3 4 and 4 3, and 5, and the others will be zeros. Okay, so to make it a true, so we can simply make the ones are true and the. Oh no, I cannot. So this is a group of. This is a group of province. So this is 1 and this is 2 and this is 3. So this will be false and this will be true and this will be true. Hey, welcome stream, man. How are you? I'm good, thank you, man. Okay, just want to write the basic thing. So if the visited will be, so I think if visited will be n. Okay. Then self, and let's say at, so the at will be if visited of at, so we're gonna simply return, and if it's not, we're gonna make it if we didn't visit it and we want to visit it, so we're gonna make it true. Then we're gonna define neighbors, so that's the algorithm set equal equal is connected of so the visited has to be like 2-dimension, has to be a matrix also. So I think you're close to getting a job. An internship, yeah, I'm pretty close to getting a job, but a job I don't think so, because I'm really still studying, and I didn't really search yet for a job, but I got some promises, like it said, and yeah, I think I'm not really that qualified yet for getting a job, but an internship, yeah. Okay, so how we make a matrix of n by n. Okay, so matrix. Oh, so okay, I want to do it to school. Okay, so the arrays, the two-dimensional. Mm. So I want to initialize a one, or do I have to make a for loop? I don't really want to make it. So I think I'm gonna do a matrix of. I think this should work. Yeah, this should work. Uh, but no, it isn't really like this. So false, false is on, and no, shouldn't really be like this. And hmm. Yeah, I don't really know how to initialize. It's about 30 minutes. I don't know how to initialize a matrix false space. So okay, so it is like this. Okay. So false n by n. Like it is it. Okay. And then I'm gonna be it's gonna be like IG visited IG and visited IG equal to is connected of I and G. So here I think I'm gonna need a nested loop. So for next one is enables for this to iterate through the columns, and then neighbors of n. So okay, so this I'm gonna make it len neighbors, and here and len of neighbors also. But now I'm gonna make a DFS of neighbors of next one, and here next two. Okay, so and then we have to start. So uh so start start g equal 0 0, and then dfs of start I and start g, and then simply I'm gonna return the it's connected. So now I'm just gonna see the it is it is I by n, so okay, so set is it self? Okay, so we have to make the sound like this. But now EG oh, and here self, I think. Okay, so visited have to also make the visited as a parameter. So here visited and here self dot and here visited. Is connected is not so I have to make is connected also the variable. So okay, so it's connected. It's connected. It's connected. It's connected. The fs of is connected. I think this is cool now. Time limit exceed. So this is a infinite loop. Type of len of neighbors. Okay. Okay, from range. I forgot the range, so int has no neighbors, is a list. Okay, so IG. Which country are you in? So I'm Tunisian. I born here in Tunisia. It's a North African country. I studied here all my life, and yeah. Okay, I'm gonna go to this and I solved it in this problem. So neighbors equal room dot current. So neighbors is a array list. It is a list. Okay, so here I have to make it. So neighbors, we're gonna initialize it to an empty list. Or not? Oh, you're not. No, no. I'm from North Africa, Tunisia. I wish I am in USA. Oh, so I really don't know what is happening. So neighbors equal room dot get current. It's a list of integer. Listed of neighbor. List integer neighbors. Visited of neighbor. Add neighbor. Oh, neighbors is. Okay, okay. So I'm gonna make it zeros. I'm gonna initialize it like this. Okay. Initialize it like this, and we're gonna make it in the last parameter. So neighbors, 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 a lot of parameters, man. So okay, let's go. Hey bro, what's up? What's the best way to get into it? Because someone brand new to it and someone who may not be smart. Doesn't matter if you are smart or not. Me myself, I'm not that smart. I'm actually dumb. But yeah, there's a helpful video to follow it. So it is 15 lead code patterns. This man, just follow its patterns, revise it, and begin with. So this is the video. Its lead code was hard until I learned these 15 patterns, and then start with the 75 problem. So in the lead code problem set, you're gonna find this lead code 75. Start with it. For every it is divided by data structure. So in this data structure, we'll devise arrays and then 2 pointers and then sliding window. So currently we are in the graph DFS. So it is a really good roadmap, this lead code 75, and you revise the structure with it. Thank you, bro. Also got this one. Hey, thank you, man. Welcome to stream. Okay, so visited of IG, less than maybe integer or size, not list. So list and this might be integer or size, not list. IG start I start G. Start I start G. IG visited of IG. You get the interviews, bro? No, because I didn't really apply to jobs yet, but I got interviews for internships. It's in January, I think, or February. So for jobs not, because I'm not really that I didn't really apply to too much of it, but internships for sure, yeah. So visited. Okay, so 34 minutes into one problem. It shouldn't be like this. So I'm used to work with it in lists, but in the matrix it changes all things. Okay, so to have this for everyone, trouble understanding the input of the main representation is a bit confusing, but look at it. Okay. So list and this must be integer or list, not list. Is connected star D star G. Okay, so I'm gonna make it. So it's connected I and G. I don't really know what is the problem here. Oh, I think here. So neighbors. Oh, okay. So solve DFS of this is a list. So this. So next. Oh, okay. So the problem is here actually. So next to. What are we gonna do here? So I think this is next one, and this is next one, and this is next one. Okay, so let's put it here and let's go. I nothing. So what? I want to return neighbors to see what is the result. So 114. Okay. So oh, so I'm gonna make this zeros. So I all I did is duplicating the. Oh no, I didn't. So 110, 110, 001, 110. Is this why it is the same input? Next EG. Honestly, I don't know what I'm doing, so we'll just see what is or how to solve it.
Yo, what's up guys, BabyBear48 coming at you one more time. Today's problem is another request from one of our friends. This was for a number of promises 547. If you have any other requests, you can email me. My contact's down below, babybear48 at gmail.com. So feel free to drop them in the graph. On maybe a graphical perspective. And if we really take a look at it, all we need to find is how many different components there are, how many connected components there are to this graph. And once we figure that out, that's really all that we're returning. Are connected components that are, I'm going to say, okay, this is the beginning of a new province. Accounted for already. I'm going to back out of this call and say I'm done. So I have one province here that I found. That first search is over. I'm now going to step out and I'm going to keep looping it. Yes, I'm going to take one for loop that's going to loop through each city one at a time, calling it that first search on it if we haven't seen it yet. Okay. So for instance, I get to
province 1, province 2, and province 3. Okay, so the visited thing shouldn't be like this. Should be false. And neighbors. Okay, so a visited of I.
I get the city. Once I'm who bit the city too, and I say, have I visited yet? No, I haven't. So let me do that first search of the city too. I jump into city two, and now I'm going to add it to my visit list. From city two, I'm going to walk through every single neighbor and see which ones are connected. I notice that three is connected. Good check. So I finish with that call, and I'm back looping through city number two again. City number four, we've checked city. Let's start at a new province. So I'm going to start a loop. I'm going to say neighbors. We continue down. These have already been visited, and by the time we get to five, we'll add one province. We see that it's on its own, and that's really it. So all we're going to be doing is a depth first search through one city at a time.
Okay, so we're gonna apply a depth first search on the lines and see what. Okay.
And I'll kind of leave this just as a placeholder. I'm going to keep track 0 by default from the start. And I'm going to return number of provinces at the end after we do the magic here. I said that I wanted to keep track of the cities that I visited as well. In order to do this kind of in an easy way, we could always use a step. I like to use steps when I can to track this, really any problem that's got this visited component to it, because we do have that nice old one constant time lookup for items that are in set. And then what I want to do is I want to loop through every city. So I want to loop through each one of these. So city 0, 1, 2, 3, 4, 5. This is an n by n matrix. So we will, so it's going to be a square matrix. So what I can do is I can say, I can say for I in range and the length of is connected. But instead of I, I'm going to use a slightly more descriptive, very slightly more descriptive word like start as our starting city. Technically, this is just going to be a number from 0 to n minus 1 inclusive, but that's also how I've chosen just to label the actual cities. I think that it's a lot, it's pretty intuitive to keep track of them that way. And then I'm going to say if we haven't visited it yet, so if start is not visited, then what I'm going to do is I'm going to say this is the start of a new province. And my number of provinces is going to increase by 1. And once I recognize that, I'm going to say let me do a DFS call that's going to start at this first city. Now,
Okay, so this is the thing. I didn't do this. Yeah, I didn't do this here.
I jump into this DFS, I'll say now that I've actually jumped into the call, here's where I'm going to add it to the visited list, the city that I'm starting from. The reason that I'm putting it up here and not here in the for loop is because when I do DFS calls and go further down the call stack, I want to make sure that I'm adding all of those in as well, and I'm not just adding the starting city in here. And from here, I'm going to use another slightly descriptive variable called end, and then what I'm going to say is for end in the range of is connected as well of the length. And so what I want to do is when I'm jumping in to say this row over here, I want to actually look at every single one of its neighbors through and through. And that's going to represent a sister city, or really a city that's connected, not a sister city. What I'm going to say is if they are connected, I didn't want to jump into DFS. So under a certain condition, I'm going to want to say, let's do a DFS on this second city. I could have called this neighbor maybe. For some reason, start and then just work in my mind. So the way we can say that is we can say if in the adjacency matrix is connected to start and end, meaning the neighbor we're looking at if it's actually connected directly, and if we haven't seen it yet. So and if and is not in visited and not in visited, then we will do a DFS on this all. So this neighbor we're going to dive in and start searching. Once we make the call, we'll add it to visited, visit all of its neighbors, etc., etc. Now I'm going to run this because that's really all that we have. Like I said, the code is super short, and I think this definitely wasn't the hardest problem that we've had to do. Run. So, pretty simple DFS problem.
Well, I think it's not the simple, man. Okay, so now the solution. Let's just see it. Okay, so Python. Yeah, like you did it. So we're just gonna copy it. So we're gonna make n is a like I did it. And it's the len of the the is connected. Uh, and then we're gonna make a set which is visited or seen. Then we're gonna define the DFS. If neighbors and adjacents enumerate a node, so this will have the index and this will have the value. If adjacent and not seen, then we're gonna add it and we're gonna make the DFS. And we're gonna make the ends to 0, so then we're gonna count the number of province here, and then we return the it number to a um, to the output. Okay, so let's just copy it and okay, so this a little bit like a node. Oh, okay. So self, this is len of is connected. Then set, a is connected. I think also. So in exchange, I don't really see that before. So here let me add self. Okay, so I think there is a missing attribute. It only has one. Missing one required argument node. What? Iteration. Okay, so okay, so let's copy that. Well, this is not the that's not the same. He used the collection. So. Oh, so he used the dict. يا محمد جوكبي ماشي. اي يا العزيز وين جوكبي؟ والله الحمد لله خويا. انا راح بيك في ستريم. So he used another method here. So he simply make the visit like I did before. It's not a set, it's a list of false multiplied by n, which is the length of the matrix, then a DFS, then to count the number of provinces, then return the count. I think so. The stream is about 49. Hi bro, I have a question. Hey, welcome stream, man. Yeah, you're free to ask everyone you want. Everything, anything you want. So reserve the route to make all paths lead to CT0. Okay. What's that? Or I think I'm gonna do this. Oh, I think I'm gonna do it tomorrow because it's already for 49. What kind of Python project have you made for GitHub since they are also important? So I made in GitHub, my last project is a Django project with which make the owner of a business can manage the interns. So it's interns management system. I made also, so let's go to my GitHub. It's not the strong one, but I think it's not that bad. So a Django project. This is it. This Laravel, it's a e-commerce project. This 3JS is a small project. Link in your GitHub. It's already in the bio here. You can check my LinkedIn, check my GitHub. I think I cannot. I think I cannot send links in the chat because yeah. Progress. Now we're not ashamed. And I have another repositories, but they are not the. I think I did a architecture agency website. I did this e-commerce. This is my first this is my first project, which is a portfolio, PHP, memory game with JavaScript, the calculator, and the basics project. Yeah, it's not the big of deal, but I will work on it surely. So how about continuing with this? I think this is a little bit challenging for me, but I can do it. Very good, bro. So I am in second year of software engineering. Thank you, bro. Uh, Connect with me in the LinkedIn if you want. And no, I'm not that good. I think. So I think it's better to make that tomorrow. Or okay, let's continue doing this. So there are n cities numbered from 0 to n minus 1, and n minus 1 roads such that there is only one way to travel between two different cities. This network from 3 last year, the Ministry of Transport decided to orient the road in one direction because they are too narrow. Oh, okay. So roads are represented by connections, where connection I equal I and AB represent roads from city to AB. This year there will be a big event in the capital, City 0. Okay. Oh. And many people want to travel to this city. Your task consists of reorienting some roads such that each city can visit the city 0, return the minimum number of edges, change it. It's guaranteed that each city can reach city 0 after reorder. Okay. So the graph was oriented like this from 0, 1, 1 to 3, and 2 to 3, and so I have to change every node to go to the 0. Oh. So here connections, you have 0, 1. This is the city 0. So the city 0 has a connection with 4, 5. So connection represent a road from city A to city B. Oh, okay. So this is the connection from 0 to 1, this the connection from 1 to 3, this connection from 2 to 3, this from 4 to 0, and this is from 4 to 5. So I have to change it. 4, 5. Oh no, 5, 4. And then 4, 0. How we're gonna do this? Think. put some music to make it. So okay, let's draw a little bit. Okay, so now we have a list of lists. We have now 0, 1 and 1, 3 and 2, 3 and 4, 0 and 4, 5. So we have to make all CDs, all roads in the direction of the city 0 because we have a festival there. So here from 0 to 1. Okay. So the 0 will always be in this side because we have to go to 0. Okay. So this set. So the 0 is always in this side, so there is no road that has to be changed. So we have to make this graph look like this, like 1, 0 and from 3 to 1 and from 2 to 3 and from 4 to 0 and from 5 to 4. This is it. And we have changed this. We have changed this. We haven't changed this. And we have changed this, which are 3, which are the number of changes, which are the number of road that has been changed. So let's draw the graph. So 0, 1, 3, 2, 2, 4 and 5. It has been like this: 1, 3 and 2, 4, 5 and 4, 0. So this is not. I'm gonna make it this. This is not. I'm gonna make this. This is false. I'm gonna change it. We're gonna start from here. Okay. Have you just been doing that lead code, or you are now on project as well? Yeah, I'm currently working on a ASP.NET project of a management of a restaurant. I will show it to you like the next video or after it, and I'm gonna present it in the uni. And I'm considering doing a project in the stream in the upcoming video. So yeah, keep in touch to see the other videos. Welcome stream, by the way. So how are we gonna do it? 1, 2, 3, 4. So 1, 2, 3 and 4. 1, 2, 3 and 4. Okay. So this is the number of roads. Okay, 1, 2, 3, 4, 5. So the first idea, like we have to initialize. So cheers, man. Hey, thank you, man. Thank you. So initialize the number of routes. Okay, so n equal len of connections, and then we're gonna make the function dfs, so def dfs of self, and let's call it right. So if it's visited, so for every one, so you have to check. How we're gonna make it? So we're gonna start from 0. Okay, so I'm gonna just put it here. So the start is 0. So it's the node 0. The node 0 is always the start node. Okay, so I have here 1 0. I think we can just swap those number. So if the 0 is here, we don't swap it, and we keep this as the value. So this is 0 1. We have now to check the 1. So now I have to check the 1. We're gonna do this. I think I have an idea of just swapping. So we're gonna swap this, we're gonna swap that, we're gonna swap that, and every time we swap, we initialize the counter. So we're gonna swap this, and we're gonna have this number. If this number is not here, so think of swapping the interior list to make 0 in the second position, and the last city visited also in the last position, not 0, from 2 to 1. Last position, and variable to store the last city visited, and counter to count the number of swap. So if we found so if we found the 0, no, we cannot. Not 0. If we found the 0 is in the if add of 0 equals 0, then we're gonna swap swap this list. So we'll have a c equal out of 0 equal out of 1, and then out of 1 equal this to swap the element, and then count plus 1 equal plus 1. If we found the 0 in the first but if the 0 is to 1 and then 1 to 3 and then 3 to 2 and then 2 to 5, oh, so we cannot. Can we do it? Okay, this is to swap it, and now the last city visited in the last position. Okay, and then okay, so after the swap, so if we swap it, so either way we have to make last city equal add of 1. Well, if we swap it right here, we're not gonna so if I swap it, so the last will be we have to go to the next city. So okay, if out of 0 equals 0, then we're gonna make the city equal out of 1, and then I'm gonna swap it. And if it's not, then we're gonna make it out of 0. Okay, so let's see. So 1 0, so the 0 is not here, so this be last visited, and then we'll have to go to this, and then DFS of, I think, so this is the variable and counter to count the number of swap. So I think then I'm gonna make the DFS of last city. Okay, so add is not a list. So self add is a position. So list of add. So connections of add of 0. Something like this. Add C equal connections of add of this just to swap. Yo bro, how are you doing? اي اهلا مين وينك؟ جوك بي. انا نخدم في الدي اف اس، تفكرك المرة البروبليم هذايا تاع لا مش هذا، هذا كي اند رومز اللي خدمته انا وياك. انا تو قاعد نخدم في البروبليم الثالث متاع الجراف دي اف اس. واني خوك مانيش فاهم شيء. المهم شحال كنت شعور. So can't buy one list. حاسس روحي قاعد ندخل بعضها والله. المهم okay, so connection of DFS and then of last city visited. توا نجم وبعد هذا كل after all that we have to return the count. Count. Yeah, we did it together. And then DFS of start. Show the problem you're working on. Maybe I can give you some tricks. This theory order routes makes all path lead to the city zero. It's not that hard actually, but I'm not. I think I'm not following the pattern of the graph DFS. So cannot assign substitution. Maybe you meant. Oh, okay. Okay, so think yourself. Is it the attribute or? Okay. Source of DFS. You want to know why this? Why I define so? Okay, DFS. When did he? Graph DFS. Why when I? Okay, so I'm not gonna give it this. Think. Okay. I'm gonna give okay. Maximum deficient depth exceeded. So it's about 140. Oh, so I think there is no break. So if we have to break if we got to here. So if or why? Oh, if at if start no if not if not at I think Okay. Okay, so it's not every time. Okay. Um, I want to print every time I want to print count to see what is going on. Oh, so it is only one time, and then he. So what did I do with the? So I think my whole approach is false. So okay, so because we have no time, I'm just gonna ask ChatGPT for this. So I'm doing, what is his name? Oh, so it's all of it. Okay, so what did he do? So how do you code yourself into job or an internship? How do you code yourself? Hey, welcome stream, man, but I didn't really understand your question. So here he's gonna build the graph. So default dect. I'm really not understanding this. So this is like the. I'm gonna ask him for this. Is a container. Oh, so it's like a. It is a dict, like a hash map. So graph equal default dict A B in connections, graph A B and B, true for original direction, false for reverse. Okay, so it's gonna traverse it. Neighbor is original, like the first one. If neighbor equal parent, then continue. If it's original, reorder. Oh, so it is already good. So it's gonna continue. If it's not the reorder, he's gonna count plus, and he's gonna reorder it, and then he's gonna return the reorder, which is the count, the variable count for us. Then df is 0 minus 1. 0 and minus 1 because it's not connecting to any one. So this one. It's really depressing to not being able to. I suggest that you transform the graph from undirected graph, then run a BFS from each node to the node 0, which guarantee you that you'll find the shortest path. Changes the root in a set so that you don't count them twice. Yeah, like you said, it's close to this. It's very close actually, but I think it's not BFS. I think it's DFS. Well, BFS. Yeah. So I already sorted it out, but we actually failed at this. I think this this is the worst stream. I didn't do the problems effectively. I hope I'm gonna do better in the next video. Um, so I think this is the end of stream. Oh, it is 18 simultaneous spectators. Hey, thank you, man. That's a lot, and the views are actually good. So I think this is the end of stream. Thank you, everyone. If you want me to produce more content, and if you want me to continue this challenge, please follow my YouTube channel, and you can connect with me on GitHub, on LinkedIn, on Instagram, and you're free to join the Discord server. If you like this video, click the like button and don't forget to subscribe. Thank you, everyone, and I think this is the end of stream. Thank you, everyone, and hope I see you tomorrow. Good night.